Hi, my name is Rosario Hanon, and this is my lab about the motion of falling objects. We'll be exploring the forces that interact with two different falling objects. A fast-moving object, which is here in my video, it's in the tracker already, it's a black ball. And this is its motion and tracked in this graph. After we put set the coordinate plane and the diameter and track the ball, we put all the information into Excel, and we got this information, the experiment information. Then we input all the mass, the initial velocity, the position in which it started, and the time step in Python. Also the force of gravity and the drag included. In this case, the constant of drag was 0.018, and the force of drag was the negative b, which is a constant times the velocity of the ball. We got the model of drag information and the model with gravity information and plotted it into the graph that's following here. As you can see, the model of using drag, the forces of drag and gravity, and the experiment are very closely related. The model of gravity, it's very close, but it's a little off. Then we followed with the towel paper ball, and here it is again in the tracker, and our graph, which is parabolic but less than the other one. We then again put our information into an Excel spreadsheet, and here's our information about the experiment. Again, we inputted the mass and the velocity initial, and the initial position and the time step, the force of gravity. The drag was a lot higher than in the heavier ball, in this case 0.0254, and the force of drag again the same, negative b, which is our constant times the velocity of the ball. We now brought this to our graph number 2, which is the object that drops slowly, and we find again that the model with the drag and our experiment are very closely related, while gravity in this case is a lot off, because the force of drag in this case is a lot bigger and makes a very big difference. And for the questions, for the object that drops slowly, examine the velocity versus time predicted by your models with and without drag. Which model, if any, predict a terminal velocity? Discuss briefly. The models with the drag, especially one in which the drag is significant, which is in the paper towel ball, because as the force of drag increases and starts equaling the force of gravity, it starts totaling a net force of 0 or very closely to 0. Thus, there is 0 acceleration and there is a constant velocity. And for our second question, for the object that drops slowly, use your models to examine the object's velocity in the case where the object is thrown downward initially. In this case, does the object reach a terminal velocity? Compare the terminal velocities, in this case, with the case where the object is dropped from rest. So we have, in the case of gravity only, we have from rest, the terminal velocity was negative 6.9. And with an initial velocity of negative 1 meter per second, we got negative 7.592. And we have how here it starts reaching approximately a terminal velocity, because like the graph is like with a constant slope in the end. And here, but here, the graph starts reaching a terminal velocity a lot sooner than in the first graph. And now we go to the case of drag, which from rest reaches a velocity of negative 1.15791. With an initial velocity of negative 1 meters per second, it reaches a negative 1.15858. As you can see, the first graph is a little bit more parabolic than the second graph, but the second graph has pretty much a constant velocity, and the first one has a constant constant at the end. And the velocity from rest and the one with starting velocity they're very, very similar, the final velocity. So this was my lab. Thank you so much for listening. I hope you have a good day.